Thanks to everyone for the first session. We have time for some questions. I'd like the speakers to turn on their videos, and if there are any questions, I haven't been able to follow the chat. Carl, I don't know whether you've seen anything in the chat that we can start with. Where is the chat? All right, I have to find it. Carl, you see anything? I found the chat. Let's have a look. Okay, so any questions that jump out?
Sorry about that. Can you hear me now?
I can now. Have you seen any questions that have come in?
Yeah, the comment on any work done on beneficiation and development technology for prospecting, processing water ice, and I think George Sowers answered that question. John Gruna mentioned that there was an LWIM study out there that Julie Kleinhens led. Julie's on vacation, so couldn't speak, but that's an excellent resource. I recommend people clicking on that link and accessing it. It's also available on the LSIC website.
Right, it's certainly very good. There's several things out there. George mentioned the 2018 workshop that was in Colorado School of Mines. We see there are efforts in Europe with Simon has talked about with the Lunar Resource Registry, and of course we are still getting data from LRO. Let's not forget that, because that's very important. But we have that whole host of other missions that I pointed out in the opening slide that need to be coordinated in order that we can use the data that to actually evaluate what is there to actually get to the point where we can get commercial interest. So I'll ask a question then of our speakers. What is the biggest hang up right now in terms of trying to get commercial interest in going to the moon to create resources?
Can I have 30 seconds?
All right, you go first, then George.
Okay, they are there. They're tentative. We've just seen a massive bubble in certain assets. I want to make sure that in terms of space resources that we are in some ways the next bubble. It's how things move. It's how things work. The question now is how we convince the mining industry to get on board, and the only way we can do that is to point to a proper campaign of selecting targets and whittling that list from 10,000 to 1,000 to 100 to 10. And that's our task. So yeah, it is happening.
Okay, George.
Yeah, I think, it's really simple. It's buying down the risk. We got to get closer to that proven reserve point. And at some point there'll be a tipping point where, the risk is low enough that the commercial side will jump in. But we got to buy down the risk both in the geologic knowledge and then also in the modifying factors. I've done a fair amount of work on the economics, trying to figure out, where the points of profitability are. And I think all that's really interesting to the commercial sector, but we need a lot more certainty. We need that ground truth. We need to be at least a good ways down that vertical dimension and geologic knowledge. And then based on that, we need to do a lot more in terms of the excavation and processing into something that's a commodity that can be sold, like liquid oxygen, liquid hydrogen, propellant.
Okay, thanks, George. Question for Simon in the chat there. Can you foresee a protocol in which a company is awarded a registration to explore a region of the moon, but then something scientifically interesting arises at that site? I'm imagining something akin to finding an archaeologically interesting site when developing an area on Earth. Is there a way to ensure such areas get protection?
Yes, we have a registration called a heritage registration. So we made all the Apollo uh, manned sites as heritage zones in accordance with, I think there's a US law that put that in place anyway. We also look at turning certain scenic areas into heritage zones because we know if we're not proactive, we're going to get flack for it. So, but we're open to, if someone says, look, this is a particular area, you should make your heritage area, we're open to it. Yeah, our main goal is to try and be a commercial entity that looks for resources locations.
Okay. So a question for Sam in terms of United States exploration roadmap. What is the next step for that? I believe League is looking at that right now. But can you just tell us the next steps for further developing the lunar exploration roadmap?
Had to find the unmute button.
There we go.
Yeah, that's a great question. So I think this workshop will be an important aspect of that, but I think in general, the roadmap is a living document. It's updated continuously. I think one of the things that there's two things coming down the pipeline. The first is this sort of idea that was started by Dr. Cohen a couple of years ago. Was we League Science Goals document is coming up to update and refresh that aspect of the lunar exploration roadmap that used the 2007 NRC report as its statement of science priorities, but we've made a decade of advances, and so there'll be in the decadal survey, sort of their most recent one, the OWL report called this out pretty specifically as the need for a lunar science goals document. The second is that the Artemis architecture remains is coming into sharper focus, and so once that happens, I suspect it would be a valuable exercise to go through the LER and assess the LER against the Artemis architecture that ultimately emerges, at least for the option A and option B efforts, and see what sort of the next steps would be and what that level of capability enables. We've heard a lot about what the policy formulations are, but the LER is pretty clear. It goes from it encompasses robotics and all the way up to field stations and beyond. And so I think without at some point there will be a field station, right? And so the trick is, what are the steps necessary to enable that, and where is the time phasing of that as you relate the LER back to the reality of the architecture? Does that answer your question, Glenn?
Yeah, thanks, Sam. Let's see. Yes, from Sean there for Simon about, have you addressed data ownership yet? Private missions may especially want this clarified.
Yes, well, there is going to be a market for private data on certain locations, similar to what we have in the terrestrial mining industry. So I see that as a big part where the full commercialization of the moon will be where certain entities have private data about certain locations, and that gives them the reason to go there. And I think it's also important that you start having that. So at some point, we will veer away from having a lot of publicly available data, which is great, and we'll recognise that. But the next stage will be, as I said, where specific mining companies, they'll need to have an edge for going to a particular location.
All right, Laszlo. One for you here from me with regard to the definition of reserve. Can you just clarify that one more time? You said it was due to specific definition. It depends on the type of mission you send.
Sure. So basically, if you have the capability to send a mission that can dig deeper, process lower concentration materials or whatever, you can consider material as a reserve that another mission would not be able to consider as a reserve if it has less capability. So basically, your definition of what is good enough to be called a reserve depends on your capabilities to excavate it and process it and change it into a commodity. So that's the main point.
Okay. Okay. All right, we're getting close to the end of this particular session. And again, one for you, Noah, just to remind everybody, how long has LRO got before it runs out of fuel?
That is an easy question with many different answers. So we are funded right now until October of 2025. At our current rate of fuel consumption, we will run out of fuel to manage momentum, change our orbit, do small tweaks in, let's just call it end of 2027. However, we are looking at ways to extend the life of the spacecraft by managing momentum through sloops. Look off to the left, look off to the right, and that brings the overall mission momentum down. Now, tomorrow we could wake up with bad news from the spacecraft, so we should never count on LRO being around for the next 15 years, but we're going to try. And so we're going to use some look into using inventive techniques. Obviously, we can't go change the spacecraft, but we're going to look at new ways to operate the spacecraft to keep it active longer. We have a set of exceptionally well-performing instruments. There's no reason for us or anyone else to stop using them, and particularly with this amount of interest in sustained lunar operations, we're all the more eager to do that. So Clive, let me just answer your question one last time. So again, there's the funding pot of money that we are now at least looking forward to until 2025, October of 2025. And we have fuel to do normal operations as they stand right now for at least 2 years after that. However, if we change priorities and turn LRO into a hybrid science engineering mission, we could push that much longer. And the MAVEN spacecraft at Mars is a good example, obviously doing very different types of science than we are, but they're looking at doing similar things. So I don't know if that answers your question, but I want to give everyone the idea that, hey, we can look at ways at sustaining that operation much longer. Again, we were supposed to be at the moon for 2 years, and here we are now 13 years later. So we reap the benefits of the hard work that we did then, and look forward to many, many years of further operations. But we do want to see an LRO-2. We want to see this armada of lunar spacecraft unified by a larger, robust spacecraft. That we have Luna H or Luna Maps, Flashlight, Ice Cube, Trailblazer, and I know I'm leaving out many others. At the same time LRO is operating is nothing, and I'm getting the flashing time zero, but is nothing short of amazing, and an opportunity to coordinate on answering probably nearly every one of these questions that we've raised here today. But without that, I would say without that coordinating mission that kind of unites them all, we maybe lose an opportunity.
That coordination is the key. So, all right.